Block 3, Section 2, Retrieval using simple queries. The topics covered are basic queries, select and from, data types, the where clause, using joins, the group by clause, the having clause, the order by clause, constructing SQL queries, and the summary. The structure of simple DML queries. DML stands for Data Manipulation Language. A simple query specification consists of at most the following 5 clauses. Select to show the attribute or the column list. From where you're going to bring the data. The table or the tables. Where the search condition, group by grouping column or column list, having the search condition. So we have seen 5 different clauses: select, from, where, group by, having. So we'll discuss each one in detail. Basic queries, select and from. So we have an activity here. Using the hospital database, run the following query. So you're already familiar with the software. So I'm going to see the details of the treatment table. Select star. Star represents everything. From which table? From treatment table. Let us see the result of this query. You are able to see 15 rows, a table with 15 rows and 4 columns. Staff number, patient ID, start date and reason, all the details of treatment table. How to develop a query? 3 different concepts. Number 1, the problem statement written in English with no reference to tables or columns. Second step, the query expressed in English which specifies the tables and possibly columns needed to answer the query. Third one, a SQL query which produces a table when executed. We have an exercise. Is the following a query expressed in English or a request or problem statement? The question is, list the name of every patient represented in the patient table whose height is greater than 170 centimeters. So what we need to list? List the name of every patient represented where? In the patient table. What is the condition? Whose height is greater than 170. The answer is, it is a query expressed in English. If we convert this expression into an SQL statement, the answer is select. What we need to select? The patient name from the patient table. The condition is height greater than 170. So select patient name from patient where height greater than 170. So you're able to see the result here. So here we choose particular column from patient table. The result. Here you can see duplicates. Say row number 2 is Harris. Row number 5 is Harris. So we need to have a method to resolve this problem to avoid duplicates. Before we go into duplicates, we have seen some examples of query and the result, the observations or the conclusion. The result of every query is a table. For example, here you are able to see a table with multiple rows, multiple columns. Here you are able to see a table with single row, single column. So here you are able to see one table with a single column title with no data. Eliminating duplicates using a keyword distinct. So on the left hand side, you can see the query. Select patient ID from treatment. So patient ID, details. Red color shows duplicates. P38 is repeated 3 times. P39 is repeated 2 times. So we need to remove these duplicates. So we can rewrite the query using the distinct keyword. Select distinct patient ID from treatment. So it is giving you P38 and P39 only once. Now the logical processing model. Provide a simple way to work out the result of any statement. Always begin with the from clause. Defines a clause by clause process for obtaining the final table. We will build up the processing model over the course of this block as you learn more SQL constructions. Example. Select patient ID from patient, logical processing. The initial specified table. Then we have selected a table called patient. From. Copy data specified in the from clause to create an intermediate table. So we have copied the data to the intermediate table. Then what we need to select? Maybe you need to select all. Maybe you need to select based on a criteria. Maybe you need to select only particular columns. So copy data in the column specified in the select clause from the intermediate table to create the final table. So finally, this is the final answer. So these tables will be different when we use multiple tables in the from clause. So when we combine tables, we'll see that details. Select distinct patient ID from patient. So it will create the initial specified table, then copy the data to the intermediate table. Then while it is selecting, it is checking distinct. So it is avoiding or eliminating the duplicates and producing the final table. So we go for the next topic, data types. SQL allows predefined data types and user-defined data types. User-defined data types are defined in terms of the SQL predefined types. We'll study this one in section 5. SQL predefined data types. Number 1, character string types. Character, or simply short form, we can use char, and the argument is L-E-N, len. Fixed length character strings of length len. Then we have, so char is used for the fixed length and varchar is for variable length. So you can specify the maximum length. Second option is numeric data types. Integer, for integer numbers, we can use short int. Small int for the small integer numbers. Big int for the big integer numbers. Decimal, p, s. Decimal numbers containing at least p digits all together. Say for example 10. With s digits after the decimal points. Say for example if you write DEC or decimal 10, 2. Overall total length is 10 and it has 2 decimal places. Then we have the numeric, float, real, double precision. Then we have the bit string types, bit len, bit varying len. Date, time types. Date, time with an attribute p, timestamp with an attribute p for the precision interval. Large object string types. So we don't study this one in SQL anywhere. Character large object size, or and next one is the binary large object size.